This is a second recording for section 12.3. In the first recording, we discussed the range, which is the difference between the highest and lowest value, as well as the standard deviation, which is the on average how far the data values are from the mean. We often also report the 5-number summary, and of course it's 5 numbers. It is the minimum value. The 5th number is the maximum value. All right, so those are easy to pick off from the data set. The middle value, which is the median. And then we have 2 new vocabulary words. Q1 is the first quartile, and it marks 25% of the data values. So you would know that 25% of the data values fall between the minimum value and the first quartile. Another 25% between the first quartile and the median, which is actually called the second quartile. And then we have the third quartile, right? And so 25% of the data values fall between here and the maximum. So what we can say about the third quartile is that 75% of the data values fall below that value and 25% above that value. So how we find the 5-number summary is we make sure, just like when you find the median, the data values have to be put in order. So we order them from smallest to largest. Then we find the min, the max, and the median, right? Because those are of the 5 numbers, right? The min, the max, and the median are easy to pick off. So cover up the second half of the numbers, and then you'll find the median of the first half of the numbers to get Q1. And then you'll do the same thing to get Q3. To get Q3, you're going to cover up the first half of the numbers and find the median of the second half. Okay, so let's see how that works. Find the 5-number summary. If you look, it looks like this first data set, they are in order. So that is the first thing that you want to check. They are in order. So the 5-number summary is min, the first quartile, the median, the third quartile, and the maximum. So those are our 5 numbers. The minimum you can pick off, and the maximum you can pick off easy enough, min and max. The median, you can either do, remember you can do smallest, largest, next largest, etc. and cross them out till you go down if you want to. All right, this one, this one, this one, this one, until you get down to the middle. So the median is 34. You can also, remember, use the n+1/2 position. So you would just need to count how many data values there are. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. So remember, it's in the 15 + 1/2 position. 16 divided by 2 is in the 8th position. So then you could just start over and count over 8. 1, 2, 3, 4, 5, 6, 7, and then you know your median is in the 8th spot. Okay. So now when you find the first quartile, you cover up the second half of the numbers, including the median. That's the most important because some people, if you include the median, you're going to get a different answer. So you cover up the second half of the numbers, including the median. So you're not going to use 34 when you find the median of these. So you're finding the median of the first half of the numbers. And so again, smallest, largest, smallest, largest, smallest, largest. So you know that this is your Q1, is 27. So do not include the median in your first half or your second half. Over here, same thing, smallest, largest, smallest, largest, smallest, largest. 50 is your Q3. So that is your 5-number summary. All right, and it just marks every 25% of the data values. We're actually going to graph the 5-number summary in a box plot in the next slide. So our second one down here, again, if you want to pause it and try to find the 5-number summary of this data set, feel free to do so. I'm going to put them in order. I'm going to cross them off when I write them down to make sure I have them off. 1, 3. They have to be put in order to find the 5-number summary. Okay. So we have them all, and you can count again both and make sure that you have the same amount. I'm going to write my min, Q1, median, Q3, and maximum. So the min and max, again, are easy to pick off, the 1 and the 10. The median, again, you can use n plus 1 over 2, or you can just do smallest, largest, smallest, largest, smallest, largest, smallest, largest, smallest, largest. And here it looks like there's 2 middle numbers. There's an even number of data values, so there's 2 middle numbers. So the median is going to be halfway between 5 and 6, which is of course 5.5. But you can always add them and divide by 2, and you'll get 5.5. So this time that 5.5 is in the middle there. We wouldn't include that, so we actually do include these when we find Q1. All right, we just cover up the 5.5, which isn't a data value, so you don't even need to worry about it. So anything less than the median, and then we find Q1, the middle of these guys, this, 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 and there's 2 middle numbers of 4, so Q1 is obviously 4. Halfway between 4 and 4 is 4. And then do the second half of the data values. Again, we cover up the median, but it's not a value of our data set, 5.5, so it doesn't come into effect. 6, 10, 6, 8, 7, 7. So our Q3 is 7. Again, you can count those up. It looks like there's 12 data values, and you could say the median is in the 12 plus 1 over 2, the 6.5 position, so you know it's halfway between the 6th and 7th position if you like. Graphs of the 5-number summary, we graph them using a box plot, or you might hear the term box and whisker plot. And how that works is you put little lines at the minimum value, the first quartile. It's only one axis, and your axis would be labeled, but this is just showing you, but you would put like test scores or whatever it was down there. Minimum, you would put a line for the lower quartile, the median, the upper quartile, and the maximum. And then you would do a box around the 3 middle values, the lower, the median, and the upper. And then you would draw whiskers to the min and to the max. So that's how that works. Note that if there are any outliers, an asterisk is put in the place of the outlier, and the next lowest or highest value is the new minimum value or maximum value, respectively. There's actually a whole process to determine whether a data value is an outlier, which you would maybe do in a traditional statistics course. In this course, we're just going to make that if a data value is just extremely high or extremely low, that there would be no question whether the data value was an outlier, okay, if we put it on a test or quiz. Examples: ages of Oscar-winning actors from 1975 to 2004, and it gives you a box plot of female and male. And this is again a good box plots are used in comparing, oftentimes like this, where there's 2 box plots on the same, so you can see, you know, that the male's average is higher, right? But you know, remember that this represents 25% of the data values are between, it looks like 42 and 50, right? That type of thing. So let's see if we can answer these questions over here. Approximately what was the median age for female actresses from 1975 to 2004? So the median, remember, these minimum, this next one is the first quartile. These are graphs of the 5-number summary, all right? So minimum, the first quartile, median, third quartile, and maximum. All right, but they're all these little vertical line segments are where these are. So if we want the median age, again, we're approximating for females. We would just look down at our axes here where our median is, and this is 30. So maybe you want to say about 34, 35, somewhere around there. If you have anywhere between 33 and 35, that would probably seem like a reasonable answer. Maybe even 35 looks a little bit better. Part B says approximate the outliers for the age of male actors so there's one asterisk. Remember that these are all outliers. All right, but we are only interested in the male, so this is the only outlier, which was looks like 76. Maybe this is 70. It looks like a little more than half. Let's go with 76. Somewhere right around there. If you have 75 through 77, that seems pretty reasonable. And the last question says approximate the minimum age of female actresses from 1975 to 2004. We want the minimum female age, and this is the minimum, which it looks like 20. Or maybe even, looks like a little bit more than that. Maybe we'll go with 21. Somewhere around there. 20 to 22, if you have that, that seems pretty reasonable. Construct a box and whisker plot for the following test score and label the axis. So with the box plot, we only have one axis, so draw it further down so you have room for your graph, and you need to label it, which is test scores. Although the ticks on the axis need to be equally spaced apart, right? We don't have to start at 0 or anything. The minimum is 77 and the max is 99. So I'm thinking if I start at 75 and do increments of 5 that are equally spaced apart, I'll have a decent number of ticks along our axis. 75, 80, 85, 90, 95, 100. Of course, you could start at 77 and jump by 3s, really whatever you want to do, right? But just make sure that the ticks are equally spaced apart, right? And that the width is the same for each one. So what we do with our 5-number summary is, remember, we're going to put a little vertical bar above the axis. Don't put it on the axis. So 77 looks like it'd be about right there, all right? Not quite halfway between 75 and 80. Q1 is almost 80, 71.9.5. Just a single vertical bar. It just, the mouse wasn't acting up there. 86.5, which is about right there. Again, above the axis. Q3 is 90.5, which is right there. And the maximum was 99, which is right there. So remember, you put these little vertical bars above the axis to represent the 5-number summary, and then you box in Q1, the median, and Q3. You box those in like this, the 3 middle values, and draw whiskers out to the min and max. Then you draw little whiskers out there, which kind of tells you a little bit about the shape of the graph. You know, in this case, 25% of the data values look like falls between 85 and 89, but another 25% fall in this smaller interval, right, which might be interesting, and 25% between 90 and 100. All right, so it sort of just tells you about the spread of the data as well. That is the end of section 12.3.